Forensic scientists can estimate the height of a person from the lengths of their bones. One method uses a function which relates the length of the femur bone, x, to the height of the person. Using this method, the heights of males and females are estimated using the following functions. For a male, m of x is equal to 2.3x plus 65.53, where mx is the height and x is the length of the femur in centimetres. For a female, f of x is equal to 2.5x plus 54.13, where f of x is the height and x is the length of the femur in centimetres. In part A, we're asked to use the functions above to estimate the height of a male and the height of a female, each of whose femur is 47.54 centimetres in length. We must give both answers correct to 2 decimal places. Well, in both our functions, x represents the length of the femur bone. We are told that this is 47.54 centimetres. So we must sub in x is equal to 47.54 into both functions. Let's start by subbing into mx, the function for the height of a male. Rounded to 2 decimal places, our estimate for the height of the male is 174.87 centimetres. Now, let's sub in x is equal to 47.54 into f of x, the function for the height of a female. Rounded to 2 decimal places, our estimate for the female height is 172.98 centimetres. Use m of x to estimate the femur length of a male whose height is 184 centimetres. Give your answer correct to 2 decimal places. Well, the function m of x is equal to 2.3x plus 65.53 represents the estimated height of a male. We are told that the height is equal to 184. So here, we should set mx equal to 184. From here, it's a matter of solving for x. To do this, we need to isolate the x all by itself on one side of the equation. The key point to remember here is that to remove something from one side of the equation, we should perform the inverse operation to both sides. Let's start by removing the 65.53. This represents addition, and the inverse of addition is subtraction. So to remove this, we'll need to subtract 65.53 from both sides. Now, we'll want to remove the 2.3 in front of the x. This represents multiplication. The inverse of multiplication is division, so what we'll need to do is divide both sides by 2.3. Rounded to 2 decimal places, we found that x is equal to 51.51. Here, x represents the femur length, which was measured in centimetres. So our final answer is that our estimate for the femur length is 51.51 centimetres. Connor's femur length is 44.2 centimetres. His height is 171 centimetres. Find the percentage error in using m of x to estimate his height. Give your answer correct to 2 decimal places. In this question, we're asked to find a percentage error. So let's remind ourselves of how to calculate these. The percentage error is equal to the absolute error divided by the true value times 100, where here the absolute error is the difference between the true value and the estimate. So to be able to calculate our percentage error, there's a few things we need to identify: the true value, the estimate, and the absolute error. Let's start with the true value. We are told that Connor's actual height is 171 centimetres. So the true value of Connor's height is 171 centimetres. Our function, m of x, uses the femur length to estimate the height of a male. We are told that Connor's femur length is 44.2 centimetres. To obtain our estimate from m of x, we must sub in 44.2 into m of x is equal to 2.3x plus 65.53. So the estimate we obtain from m of x is 167.19 centimetres. The absolute error measures how far off the estimate is. Formally, it's the difference between the true value and the estimate. To find it, we simply subtract these numbers away. Here, our absolute error is 171 minus 167.19, which is 3.81. Now that we know the absolute error and the true value, we can calculate the percentage error by subbing these values into the formula. Rounded to 2 decimal places, our answer is 2.23. Since this is a percentage error, we should have a percentage sign at the end of this. So our final answer is that the percentage error is 2.23%. Find the length of a femur for which the estimated height of a male and the estimated height of a female are the same, and find this estimated height. Well, m of x is equal to 2.3x plus 65.53 represents the estimated height of a male. F of x is equal to 2.5x plus 54.13 represents the estimated height of a female. We want these to be the same, so we should set these two expressions equal to each other. Our goal here is to solve for x. Notice that we have more than one term which involves an x. The strategy here will be to group all the x terms on one side of the equation and everything else on the other side. Here, I'm going to group my x terms on the right-hand side and everything else on the left-hand side. To begin, I'll remove this 54.13 on the right. This represents addition. The inverse of addition is subtraction, so to remove it, I'll want to subtract 54.13 from both sides. Next, I'll want to remove the 2.3x from the left-hand side. This is representing addition, and the inverse of addition is subtraction. So to remove it, I'll need to subtract 2.3x from both sides. From here, we can do some simplification. 65.53 minus 54.13 is 11.4, and 2.5x minus 2.3x is 0.2x. We're now quite close to isolating x. The only thing left to get rid of is the 0.2 in front of it. This represents multiplication, and the inverse of multiplication is division. So to remove multiplication by 0.2, we should divide both sides by 0.2. So we found that x is equal to 57. Here, x represents the length of the femur bone, and the unit for this is centimeters. So our answer here is that the length of the femur is 57 centimeters. So we found the length of the femur where the estimated height of a male and the estimated height of a female are the same. We're also asked to find this estimated height. To do this, we can sub in the 57 we found into the function m of x is equal to 2.3x plus 65.53. We found that our estimated height is 196.63 centimeters. It's worth pointing out that we would have got the same answer for the estimated height if we had subbed in x is equal to 57 into f of x instead of m of x. This is because we found that 57 was the x value, which makes m of x and f of x the exact same. The ponderal index is a number which relates a person's height to their weight. The formula for the ponderal index p is p is equal to m divided by h to the power of 3, where m is weight in kilograms and h is height in meters. In the first part of the question, we're asked to find the ponderal index for a person who is 1.60 meters tall and weighs 72.5 kilograms. And we must give our answer correct to one decimal place. In our formula, m represents the weight. We are told that our weight is 72.5 kg. So here, m is equal to 72.5. In our formula, h represents the height. We are told that our height is 1.60 meters. So h is equal to 1.60. To find the ponderal index p, all we have to do is sub in these values of m and h into our formula. So, rounded to one decimal place, we found that our ponderal index is 17.7. In the next part of the question, we must rearrange the formula, p is equal to m over h to the power of 3, to give a formula which will give the height of a person in terms of their weight and ponderal index. In our formula, h represents the height. We're asked to rearrange our formula to give height in terms of the weight and ponderal index. In other words, we need to rearrange the equation into the form h is equal to something. The key point to keep in mind when rearranging equations is the following. To remove something from one side of the equation, perform the inverse operation to both sides. The first thing I notice here is that we have a fraction on the right-hand side, and the h term is in the bottom of the fraction. It's quite awkward having the h here, so a good idea would be to eliminate this fraction. At its core, a fraction represents division. M over h to the power of 3 means m divided by h to the power of 3. Well, the inverse of division is multiplication, so if we want to remove division by h to the power of 3, we should multiply both sides by h to the power of 3. Now that we've got the h out of the bottom of a fraction, things are looking a lot cleaner. Remember, our goal is to isolate h all by itself on one side of the equation. To do this, we'll need to remove the p and the power of 3. Let's start with the p. This p is being multiplied by the h to the power of 3. The inverse of multiplication is division, so to remove multiplication by p, we should divide both sides by p. Now, we'll need to remove the power of 3. The inverse of a power of 3 is a third root. So here, we should find the third root of both sides. We've managed to rearrange our equation into the form h is equal to something. And this is precisely what we needed to do. H is equal to the third root of m divided by p. Mary has a ponderal index of 13 and a weight of 67.5 kg. Find her height. Give your answer in meters, correct to 2 decimal places. In this question, m represents the weight measured in kg. We are told that Mary's weight is 67.5 kg. So here, m is equal to 67.5. P represents the ponderal index, and we are told that Mary has a ponderal index of 13. So here, P is equal to 13. In the previous part of the question, we found a formula which allows us to calculate the height h in terms of m and p. H is equal to the third root of m over p. Well, we know the value of m and the value of p, so to find our height h, all we have to do is sub these values into this formula. Rounded to 2 decimal places, we found that h is equal to 1.73. h represents the height in meters, so our unit here is meters. So our final answer is that Mary's height is 1.73 meters.